Hey there, Algebra, and we're going to continue working in Chapter 9 here. You're going to get introduced to something called the quadratic formula today, and that's what I have right here on the screen. Okay, and you're like, wait, this is just a bunch of letters and stuff. Here's where they come from. Okay, we want to make sure that our equation is set equal to 0. So we're talking about the coefficients, right? So how many x squareds I have, that's ax squared, and then it's bx. So that a value is going to get pulled out, and we're going to throw that in some different places here, right? So a goes here and here, and I'll show you how that works. B, again, this is the coefficient. Okay, so we're going to flip-flop the sign to get started, and then we have to square it in the middle, and then C, that gets used in here, and I'll show you exactly kind of the expectation. We've been dealing with these quadratics just a little bit, so I want to show you some places it gets used, okay? So 101 uses of the quadratic equation, nifty little website. Been kind of showing it off just a little while. So it started around 3000 BC with Babylonians. So if you're like, man, this new math, it's terrible. Like, well, remember, this has been done for a long time, which means there's been a lot more kids in the world that felt exactly the way you do. Like, what do I have to do this for? Because part of what we do here in algebra. Okay, I'm not going to make you prove the quadratic formula. That's one thing that's going on here. All right, so it can be used in some origami and making sense of proportions as we deal with that. If you're big into art, we're going to talk about the golden ratio. So the square root of 2, trying to deal with that. And it's about 1/3, stuff like that. So what happens is that's the most pleasing place to put something in your art picture. Then we have most of your cabinets, right? Look around your kitchen, right? The ratio of the height and width, it's going to be on a golden ratio because it's very pleasing to the eye. So it gets used in a lot of places. So you can filter through here. We start to look at some different variations. Notice all the x squareds, y squareds going on, conic sections. We'll do that in Algebra 2. And then they have a secondary website of some more uses. We talk about things, right? The quadratics are going to be curves, right? And that's probably a good thing because, you know, if I'm on a plane, I'd like to land in a nice curve. I don't want to land in a linear fashion because planes only land linear once. You know what I'm saying? All right, so here's our formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, we got to commit that thing to memory. We'll get that thing straightened out. Okay, so other than that, some things that I'm thinking about today are how can I solve, right? How can I solve these quadratic equations? So we're up to solving. Well, first thing is I would like to factor it because that means I don't have to do all this work that I'm about to do. So number one, I'd like to factor it. Second thing is, right, if I have x squared, but I'm going to use a 0. If I don't have x to the first power, then I'm thinking I'd like to use the square root method. All right, and that's what we did in the last lesson. Okay, so, and then step 3 is we're going to add the quadratic formula. Why do I have the quadratic formula? Because some things just are not factorable, which means I can't figure out what's supposed to make 7 out of 60. Okay, so we're going to pretend that happens. So maybe I'm just really bad at factoring. And I'm like, you know what? There's got to be a way to do this without having to factor everything. And this is what it's going to be. So here's what we got. A equals 1, because there's 1x squared. B equals -7, because that's what I have here. The sign goes with it. And C equals -60. Man, these are some bigger numbers, right? Remember, it was negative b plus or minus square root of b squared minus 4ac. Now, if I write it, it doesn't help you memorize it. So you're going to have to write it sometimes. So -7 is +7 plus or minus the square root of -7 times -7 is 49, right? I expect that you can do that and plug 49 in here. -4 times 1 times -60. That part I also want to see written out, and I'll tell you why in just a second. So let's make it 2 times a is 1. So I'm going to leave that as plain old 2. All right, the next thing I'm going to do is I'm going to go in here. I'm going to look for how many negative signs I have. Well, I have 2 of them. So what's a negative times a negative? That's a positive. So here we go. 7 plus or minus square root of 49 plus. Now I'm actually going to multiply this together. So 4 times 1 is 4. And that times 60. 4 times 60, that's going to be what? 240? Okay, 4 times 60. All right, you got it. Okay. 240. And it's all over 2. Okay, so let's see what else we got here. We're going to have to put those together. So plus the 49, we're at 289. So 7 plus or minus square root of 289, and it's all over 2. Well, what happens if I try and take the square root of that? Oh, man. Wait, that one's perfect. Hey, look at that. Okay, 7 plus or minus 17, and it's all over 2. All right, so if it happened to be perfect, that means I just didn't spend enough time trying to find the factors. What are the factors of 60 that subtract to give me 7? Well, it's not 6 and 10, so we'd have to work back through it. All right, so what this means is we'd be able to factor it. Okay, so we're going to find out what they are in just a second. Remember we had square root method, plus or minus type of options? I have the same thing happening right here. So what I have to do is go through my two different options. 7 plus 17 over 2, 7 minus 17 over 2. So 7 plus 17, that's 24 over 2, so that's 12. And 7 minus, well, that's negative 10 over 2, and that's negative 5. So the factors of 60 would have been 12 and negative 5. All right, now, I did want to give you one of these that works out before we get into ones that we deal with decimals. Okay, so if this square root of 289 became like 17.1, I would do all the same stuff. We're just going to deal with a decimal. But if it comes out to be a perfect square, that means we could have factored it. And that's okay. Actually, it's more than okay. Yeah. All right, let's try another one. So A equals 1, B equals negative 1, and C equals negative 1. So these numbers, they're not as bad as the other one, right? So let's keep track of what's going on. So negative B becomes negative negative 1 plus or minus. Negative 1 times negative 1 is 1, minus 4 times positive 1 is A, and C is negative 1, and it's all over 2 times 1 is just 2. 1 plus or minus square root of 1. Again, I'm going to count my negative signs. I get 2 of them, so it's plus 4 times 1 is 4 times 1 is 4 still, and it's all over 2. So I get 1 plus or minus the square root of 5 over 2. All right, do we know the square root of 5? No, we don't know the square root of 5. I know it's a little bit more than 2. All right, so square root of 5. Let's go with 2.2. So 1 plus or minus 2.2 over 2. So we're going to go through our two different cases. So 1 plus 2.2 over 2, 1 minus 2.2 over 2. So if I add 1, I get 3.2. I'm going to divide that in half. All right, so 32 divided by 2 would be 16. So this is 1.6. And over here we got negative 1.2 over 2. So we're going to be at negative 0.6. All right, so there are two solutions. Okay, they're rounded off a little bit. So if I plug them in, I'm going to have a little bit of trouble getting that 0, but we get the idea. So if it's not perfect, we're just going to use the decimal and work with it that way. All right, we got one more, and there's all sorts of stuff going on here. First of all, it's not all on one side, so I'm going to add 6x. Now I have x cubed, x squared, and x. They're unlike terms. Now, the other thing is, I know something has to be done because it's called the quadratic formula, and this is a cubic equation. So I definitely can't do the quadratic formula right now. So let's divide by the GCF. And it looks like 4, 16, and 6, 2. And they all have an x, right? So I'm going to take out a 2x, and then I can get this thing to 2x squared minus 8x plus 3, and it equals 0. So first thing I'm going to do, I'm going to use zero product property. I'm going to find out this 2x equals 0. So x equals 0. So now I get to ignore it. You're ignored now. A equals 2, B equals negative 8, and C equals 3. And we're going to start plugging those in. Do you have memorized yet? Negative B plus or minus square root of B squared minus 4AC all over 2A equals X. All right, there we go. So negative, negative. So we get 8 plus or minus. Negative 8 times negative 8 is 64 minus 4 times A times C. And it's all over 2 times A. So 2 times 2 is 4. So 8 plus or minus 64. I see one negative sign. Okay, so I need 8 times 3 is 24, and it's over 4. Whole thing. 8 plus or minus. Let's see, we're going to take out the 4, so we're at 40 over 4. Again, not a perfect square. 8 plus or minus. It's going to be 6 point something, right? You're always thinking about what number is it close to that, it's pretty close to either 36 or 49. So let's find the square root of 40. So when it says 6.3, I'm like, yeah, I'm down with that because it was between the numbers I thought it was, 36 and 49. All right, so let's go from here. Let's go 8 plus 6.3 over 4, 8 minus 6.3 over 4. All right, so let's take that 8 plus 6.3. Okay, so it's 14.3, but we still have to divide it by 4. So if you can do that as some calculator work, I think that's good. 3.575. And we'll do 8 minus 6.3, and that's going to give you 1.7. But I could divide it by 4. So 0.425 becomes my two solutions. Right, so that's the quadratic formula. That's how we solve quadratics when they're not factorable. Okay, so notice this one was a complete mess. We didn't even check this one, but is 1 times 1 is 1? Are the factors of 1 that are 1 apart? Well, the only factors are 1 and 1, which are 0 apart. So that means we couldn't factor here. We can double check here as well. 2 times 3 is 6. Factors of 6 are 1 and 6 or 2 and 3. I simply cannot make 8 out of that. So that's how I know that I must use the quadratic formula to solve these. So that's the quadratic formula. We'll keep working on it, but you're going to spend a little time, get that formula memorized. That makes it a little bit easier. And make sure you have your calculator handy because we're going to be looking for some decimals here, guys.